Dear participants, can you hear me? Participants, can you hear me? Yes, it is time for us to start our technical session 2. The speaker is the same person, Mr. Kishore Kumar, software engineer, EC design system. He is going to deliver a talk on understanding sensing actions. Now I request Mr. DP Kishore Kumar to take this session. Thank you.
Hello?
Yes, sir.
Am I audible, sir?
Yes.
Sure. So let's start session 2. So understanding sensor action. So if you have any queries on session 1 or any doubts, you please ping me. So I can share the PPT and steps for the code once all the session over. Within today, I can send a document to you. So they can share with you. So don't worry. So yes. So is it visible to everyone?
Sir, your screen is visible.
Okay, sir. See, the size of the SD card can be variant. So whatever SD card has be available from you, you can use any variant. So whether it is a 1 GB or 2, but please go ahead with the 2 GB minimum SD card. So 2 GB is minimum variant. So you can use 2, 4, 8, 16, 32. So what are the size you you just use it. So based on the storage, you can able to, whether you use 32 GB or 64 GB, you can able to store many files, softwares, you can able to install it. So all the stuff has been. So based on that, you can choose the variant. What are the variant you need, whether 8 GB or 16 GB. So let's see how the sensing actions have been done. So sensors is the main part. So in today's world, sensors plays a major role in all the things. So whenever we take each field like agriculture, hospital, so medical field, industry field, so any other field, sensors plays a vital role. So sensors are the main thing. So we are using microcontroller to interface this sensor. So we can't able to fetch the data directly from the sensor. So we can using controller can able to fetch the sensor data. So that's why we are using controller. So like a human being, so without brain, human being can't able to think or sense what are the sense they having. So they can't be able to use without the function of brain. So likewise, without microcontroller, we can't be able to fetch the sensors, whether it is an analog type sensor, digital type sensor. It is hard to fetch the data. So microcontroller is mandatory. So it is the brain of the thing. So sensors plays a vital role. So for example, if you take a medical field, so each person has a minimum required sensor. So whenever patient is admitted, their heart rate, their pulse rate, their oximeter level. So during this pandemic situation, so there are many sensors like defaultly they are using pulse oximeter for maintaining the measuring the pulse of the oxygen content PaO2. So some of the sensors has been made. Whenever you take agriculture field, so automatic harvesting. So automatic watering. So all has been done with the use of sensor. So sensors the main reason. So we go for controller mainly for to fetch the sensor data. So here we can see some of the basic sensors what can be interfaced with Raspberry Pi and the working of ultrasonic sensor. So how ultrasonic sensor interface, how the code has been. So I can show the demo of ultrasonic sensor once the sensor session gets over. I can show how to plug the ultrasonic, how to write a code, how to execute it, how the output will be. All things I will show it. But other than that, I can tell the details about some other sensors. What other sensors has to be used, has to be interfaced with the Raspberry Pi or any other controller. So these are the basic sensors we are going to see in today's session. So one is vibration sensor, first one. So then ultrasonic sensor, touch sensor, smoke sensor. So temperature sensor, magnetic ray, soil moisture, PIR, IR, RFID reader, which is NFC, and humidity sensor. So there are a number of sensors other than this, but I just explaining some of the basic sensors, so you can able to search what are the things you need. So for each purpose, there is a sensor nowadays. Whether you need to measure the heartbeat, you can go for heartbeat sensor. So pulse rate means pulse rate sensor. So like soil moisture. So what are the purpose you need? Based on the purpose, you can choose what are the sensors you can be able to need. So uh, for usage purpose of sensor, you need to interface with the microcontroller. So let's see what are the sensors. So mainly there are two types of sensors actually. One is digital type, and is analog type. So digital type means you already know its data has been in either 0 or 1. So like Boolean, so yes or no. So it's only in bits. So whether it's a uh, high, high means 1, low means 0. So this is how digital sensor works. So digital sensor means defaultly it gives only two values, either 0 or 1. So another type is analog sensor. Analog sensor means you already know it's a pulse wave form. It gives data based on the ADC in which it has inside the microcontroller. Based on the ADC, whether it is an 8-bit ADC, we can able to sense the analog value from 0 to 255. 0 to 255 means 0 to 2 power n. So based on the values, it converted into a voltage level. So operating voltage divided by total number of frequency, you can get the voltage value. 5 divided by 255 means you can get the voltage value. So this the internal conversion done in a microcontroller. How the analog values has been converted. So whenever in digital sensor, 0 means 0 volt, 1 means 5 volt or 3.3 volt. In Raspberry Pi, it's a 3.3 volt. Whether you take Arduino or some other controller, it is a 5 volt. So based on the controller, the digital sensor data has been varied. So, but it is an output. So it gives only two values. Other than 0 or 1, it doesn't give any value. But in analog sensor, based on the ADC, it has whether it is a 8-bit ADC 0 to 255, whether it's a 10-bit ADC 0 to 1024. So 0 to 2 power n. N means how many bit ADC you have in default in the microcontroller. Based on that, it can able to calculate. You can able to, if you using an 8-bit ADC, whenever for example you take a buzzer. So buzzer is an analog value. So you can't able to give one to buzzer to get power on other than LED. If you take LED, you can give one. So LED gets high because one means the controller had deliver an output of 5 volt to that LED. So the LED gets power. So 5 volt data has been given. So whenever it is in digital. So in case of analog, so we can't able to give one. You can able to give one, but if you need to switch on the buzzer, maximum sound you need to. Based on the ADC, you can able to give the value. If it is an 8-bit ADC in your microcontroller, so whether you need to give the maximum sound to a buzzer, maximum value, voltage value, you can mention 255. So 255 means the microcontroller internally convert the 255 into one voltage value. So based on the formula like operating voltage of that microcontroller divided by maximum number of bits it can be handled, maximum number of ADC. Okay, so It means 5 volt. Just a minute. So this is the formula. So operating voltage of controller. So divided by maximum data from ADC, which are ADC used. This is the formula. So whenever the operating voltage is 5 volt, 5 volt means 5 divided by. So whether my working screen is not visible, so just a minute. So is it visible now?
Sir, visible.
Okay. So this is the default internal conversion done by the each microcontroller, not by manually. So if you need manually, you can able to do this. But this is the internal conversion done by the microcontroller, each microcontroller. So operating voltage of the controller. So whether it is defaultly operating voltage of Raspberry Pi and microcontroller, other than Arduino, all the things are 5 volt. So 5 divided by maximum data from ADC means if you use 8-bit ADC, so 2 power 8 means 256. So 0 to 255, so you can give 256. So when you divided this, it can give the value. So if you use calculator, so 5 divided by 256 means, so 5 divided by 256 means 0.019, 0.01953 volt. So this is the, if you give 1, if you give analog value as 1, so 1 has been taken as 0.0195 volt by the microcontroller. So when you give 256, 256 into the 0.0195 gives 5 volt, and this cross multiply, the value gets given. This is how the controller has taken the analog values given by the user. So this is how it treated. So how data this is not a manual conversion. This is automatic conversion by each microcontroller based on ADC. So is it clear? Is it clear how the analog value has been converted and given to analog sensors? So, okay. So this is how the data analog value can be there. This is the two types of sensors. So whether it is an analog sensor, so analog data has been used. It's a digital sensor means zeros and ones. So here we are showing a vibrate sensor. Vibrate sensor is one of the analog sensor. So ultrasonic is one of the digital sensor. Touch sensor is digital sensor. Smoke sensor is analog sensor. Temperature sensor is analog sensor. Magnetic reed switch is digital sensor. Soil moisture is analog sensor. PER sensor means is a digital sensor. IR means it's digital. RFID means NFC. Say it can't it not comes under a sensor. It is a module like NFC. So humidity sensor is analog sensor. So let's see some detail about how what is the sensor. So what are the purpose it has been used. So first one is vibrate sensor. So I already told you vibrate sensor is an analog sensor. So it gives analog data. So sensors, all the sensors has been an input sensor. So we doesn't need to give any input to the sensor, right? All the sensors has been a output module, input module, which is it takes the data from the environment. It just fetches it and gives to the controller. The controller use controller to fetch the data from sensor and view it by just printing it. So that's the main reason each sensors has been so link. So I will share you the PPT. So all the things once the session over. So it's not. Yeah, each sensor has their own specifications. So these are the sensors we have tried and used. So there are many sensors has been interfaced with the different microcontroller. So each sensor has their own specification. So this is one of the defaultly vibrate sensor means this type of vibrate sensor. It acts on a 5-volt vibrate sensor. So it has 3 pins. So VCC, ground, and signal pin. So VCC means it acts as a 5-volt sensor. So it powers only in 5-volt. So ground means you just connected to ground, and it is a signal pin. So based on the type of sensor, we can just give it to a whether it's an analog sensor or digital sensor. We can fetch the data based on that. Here it is an analog sensor. You just plug it with an analog pin. So the vibration sensor is just an accelerometer. So based on the acceleration of vibration tilt of object, number of vibration has been detected. Based on the vibration, the output terms of voltage has been given. So the voltage data has been viewed by ourselves. When no vibration is detected, the vibration sensor output is 0, which is low voltage. So each one has a voltage value. So when each sensor gives a voltage value. Output also voltage. So whenever a microcontroller like Raspberry Pi or other thing, whenever it gives zero as a zero value to a sensor or some other component, the controller thinks zero as a 0 volt and push the 0 volt to a component or a sensor or whatever things we have connected in the GPIO. It gives us a 0 volt. So whenever the user gives one to a microcontroller, the microcontroller understands the one as a maximum voltage, operating voltage, 5 volt, and gives the output result as a 5 volt to the components or the sensors connected to the Raspberry Pi or any other controller. So each controller works like this. So each output is a voltage value. So whenever it's a digital, 0 or 1 will be available. When it's analog, I show you how the analog values has been internally converted. When it is an 8-bit ADC, whenever the user gives a 255, so the microcontroller internally converts 255 as a voltage value. 255 into 0.019, so the output will be 5 volt. So output will be 5 volt. So operating voltage has been attained, so the data has been fetched. So this is how it works. So it is one of the vibrate sensor. So you can able to use the vibrate sensor in many areas. Like for example, if you take earthquake detection. So here already mentioned. So whenever earthquake is attained, there is a vibration in environment. So they placed a vibration sensor, not one vibration sensor. They placed n number of vibration sensors all over the places to detect it. So whenever vibration detected, based on the vibration levels, it gives the voltage value. So based on the vibration, they set the value. Whenever the vibration gets increased from this value, just alarm it as an earthquake alarm. So then they have another earthquake. This is used for just detection only, whether there is an earthquake. To measure it, we use Richter. So we measure it using some other instrument. But for detection purpose and alarming, they used vibration sensor for this purpose. So this is how vibration sensor works. For another example means if in industry. So in industry, so now we are moving for industry 4.4. So sensor plays a major role in industry itself. So each machines has been placed with the vibration sensor, with the defaultly with vibration sensor. So whenever the machine gets old or need to be repaired, the vibration gets more in machine. So that's how you can able to know based on the vibration whether the machine has to be repaired or it needs to be cleaned or some other things need to be done. Because whenever machine gets more vibration, it takes more number of voltage. So current consumption has been more. So all those things get more. So the efficiency of the machine gets lowered. So before it gets low efficiency, we need to repair it or need to service it. So based on the vibration, we can able to set automatically a message alerting system to a service person, whether this machine has to be repaired or need to be verified. So whether it is properly worked or what is the reason for the more number of vibrations. We use vibration sensor. So there are many areas where vibrate sensor is. So these are the some of the areas. So it is one of the analog type sensor, so we can able to use it. So next is ultrasonic sensor. So ultrasonic sensor, ultrasonic waves. So ultrasonic sonic waves, sonar waves are used to find the distance in water areas or any areas. You just feed a beam, high powerful beam to a area. So it gets reflected and hits the object and gets reflected. So that based on the time, we can able to calculate the distance, how far the object has been detected from your place. So ultrasonic waves in sonar we can use, but this is a low power ultrasonic sensor. So this is used to find the minimum distance from 2 centimeter to 4 meter. So it is the range of this sensor. So this is how this sensor works. So it is one of the digital sensors. So it has 4 pins: VCC, trig, echo, and ground. So VCC means it operates in a 5 volt. So another thing is ground. So then trig and echo. Trig pin is used for triggering purpose. So in each ultrasonic sensor, I will tell how to configure sensors in Raspberry Pi. So I will tell you. So once the sensor PPT gets over, I can show you how to interface this ultrasonic sensor and how to work with the um, Raspberry Pi. So I will tell you. So once the basic of the sensor gets over, so I will show you in this section. So I can't be able to show all the sensor working. So due to less time, so I can able to show the ultrasonic sensor, how it is interfaced, how it is worked, how the data has been fetched, how the code has been done. So I can show you the demo of ultrasonic sensor. If it is possible, if I have time, we can see some of the sensors in afternoon session also. But I can try to show the demo of maximum thing. But I can tell you how to interface some other sensors other than ultrasonic and RFID. So all things I can tell you. I can't be able to show you, but I can tell you. So it's a VC trig, echo, on ground. Trig pin is used to trigger the working of ultrasonic sensor is you need to trigger a pulse. So that pulse has to be transmitted from the T. So this is a T pin. So it is a transmitter. R means receiver. So the wave has to be transmitted from trig pin to via this transmitter. So it transmits via air and goes and hits the object and gets reflected back. And the reflected back wave is received in a receiver. So received wave. So based on the time interval, we can able to find the distance of the object. So I will tell you how this ultrasonic sensor, how to code this in later session after the sensor PPTs get over. So I will tell you how to code it. So ultrasonic sensor is used to measure distance between the different objects using sound waves. So it measure, this is how this works. So it is a low power ultrasonic sensor. So it can't able to use to pass the ultrasonic waves inside the water. So whenever you're using sonar waves, it is a high powerful beam, high powerful waves, sound waves. So it can able to transmit inside water or air to a long distance without losing any power. It is a low power. It acts only in a 5 volt. So it can't able to interfere inside the water. So it can reflect it back from surface itself. It can't go inside the water. So purpose of this ultrasonic sensor, you can see n number of areas where the ultrasonic sensor is used. Like we said at first session, I told you about automatic ticket tolling system based on camera. So whenever the camera captures the number plate, it automatically fetches the image and converts it to a bit. Can store it and print it in as a receipt, and you can give it to a customer who are waiting it. So whenever the camera gets taken the snaps of the number plate without the vehicle reaches the person, so it is quite wrong. So it can't able to process n number of images and take one particular image. It is a vast process. So we use ultrasonic sensor at two ways based on the distance. So we can place it before the mid of the ticket tolling and what ticket tolling person's box, and also from above it, from top itself. So based on the both ultrasonic sensor reading, whether the object is a car or vehicle or there is a no object, whenever the object is detected, based on the object, the camera gets on. So it doesn't power on and take snaps all the time. So whenever it detects the object, it reaches the position, correct position. It just scans for the number plate, whether it's a car or bike. Based on that, it snaps the number plate and it gives the images. So that's where we use ultrasonic sensor, and also in many areas ultrasonic sensor is used for before behind the car for what whenever we taking a reverse. So whenever they interface with a high power ultrasonic sensor, but ultrasonic sensor is fixed behind the car. So when you get reversed, so based on the object behind inside, so whenever we reach close to the object, it gets alarmed or some other things as well. Now they placed a camera itself behind the car to check whether behind any object is find or not. So ultrasonic is meaning for you can able to use it for any other thing. And also they used for water tank measurement, automatic water tank measurement, so that the water can, whenever the motor gets filled on, so to prevent spillage from the tank, overflow from the tank, you can able to stop before the water gets overflow from the tank based on the ultrasonic sensor. So automatically it gets the motor gets switched off whenever the water gets to up to a level. So their human working has been minimumed using this using sensors generally using sensors. So this is how ultrasonic sensor works. It's one of a digital sensor. Okay. So touch sensor. So everybody know touch is a resistive type sensor. There is a two type: resistive type, capacitive type. Resistive type means it just connected with the resistor. So whenever it sets, it's a passive element. So whenever it touch, the circuit gets closed and the data has been given. So it is a digital type sensor. So it gives only two values, either 0 or 1. So either 0 or 1. 0 means 0 volt, 1 means 5 volt. It is a capacitive touch sensor with direct physical touch. Based on touch force and pressure, what are things you need. It doesn't scan for fingerprint. It's a capacitive touch only. So whenever the object gets touched, the data has been signal has been passed. It has three ports: VCC, ground, and signal pin. So this is a VCC means 5 volts. So so I'm showing the sensors. All the sensors has been worked. Minimum operating voltage is 5 volt. So VCC 5 volt, ground, signal pin. Signal pin it is an out pin. So whenever touch is touched, it gets signaled 1. When not touched, it's 0. So 1 means 5 volt, 0 means 0 volt. So this is how it works. So you know where to use touch sensors, all the things. So whenever for example, if you um, you place the light to a garage or other things, so whenever you touch the door, the light gets automatically on, so that the garage gets powered on. So you can able to use the touch sensor, and other also many other sensor you can able to use. But for minimum usage, I am sure telling like an example as a touch sensor. So you can use it wherever you want it based on your purpose. So you can use touch sensor instead of alarm. So instead of pressing an alarm, you can use touch sensor. Whenever a person comes and touches your door, the person inside gets an alarm that some other person has been come in front of your door. So you can able to go on instead of alarm. So you can just whenever the person click it, you just use a GSM instead of alarm sound. So the person gets an alarm so that instead of alarm they get a message. So some other person, it's easy to open the door. Or something. So based on the purpose, you use touch sensor. So it is one of the digital sensors. So another sensor is a smoke or gas sensor. So it is an analog type sensor. So it is a 4 pins. So it acts as both analog digital, but maximally it's analog type sensor. So based on the smoke or gas leakage, it can able to find. So there are different variant of sensors. So based on your requirement, the sensor has to be changed. In smoke sensor itself, it has MQ2, MQ4, MQ8. So you can select which variant of smoke sensor you want based on the gases or things you need to measure. So for LPG leakages, we use MQ2 sensor. So whenever actually LPG is a high weight liquefied petroleum gas. Okay, so it's not on gas, it's like a liquid. So whenever it gets it's high weight, so it always settled in the floor only. So whenever there is a gas leakage, while opening the windows, it can't able to make the gas to outflow. So it just settled in the surface only. So whenever there is a leakage in LPG, you can the smoke sensor directs and automatically power on the hoses for water flow. So it can able to clean the surface around the cylinder. So there is no gas settled in the surface. So gas settled in the surface, so it can be able to remove it. So this is how it used. For MQ2 sensor, LPG, butane, propane, methane, alcohol, hydrogen, all has been directed using this MQ2 sensor. So it is a gas or smoke sensor. So for fire indication, we can't able to use this. So we can use this, but for fire indication, there is a fire detection sensor, fire sensor. Can you use fire sensor for fire detection? Okay. So next is temperature sensor. Smoke sensor is one of the analog type sensor. So next sensor is temperature sensor. Temperature sensor is we use LM35 for temperature sensor. So it is one of the easily usable temperature measurement sensor. For high purpose for measuring the body temperature for all the stuff, so we can go for Omron thermal sensors. For low power, for just measuring the environment temperature. For minimal purpose, we can go for LM35 IC. So IC is LM35 is mainly temperature IC. So it is interfaced in a board and gives 3 pin. So it has a one signal pin and one VCC on ground pin. So it can measure temperature more accurately than thermostat. Other than thermostat, it can able to measure accurately. But compared to Omron and high-end thermal sensor, it is a low efficiency. But compared to thermostat, it is high efficient. Can able to measure the minimum temperature. So for the minimum temperature, like if you just measuring the room temperature or some other thing, you can go for LM35. So this is one of the analog type sensor. So data has been in analog format. So next sensor is magnetic reed switch. So magnetic reed switch comes in two main varieties: normally open, normally closed. Okay. So it's a reed switch. So whenever it's like a magnet. So whenever north and south pole attracts each other, so north repulse. Likewise, it works. So it acts as a switch. So it has a two ends. So one end is north, another one is south. So it gets attracted to each other. Whenever it gets closed, the data will be 1. Whenever it gets open, data will be 0. So you can use the automatic uh, lamp light on off using this magnetic reed on your door. Just stick it to a magnetic door to one end, one side of a north to on another side of south to a gate. So whenever the gate gets closed, the value becomes 1. So you can write the code whenever the value gets 1, you can you just switch off the light. So whenever the door gets open, the light gets on. So whenever the value is 0, can able to use. So many purpose you can use magnetic reed switch. So this is how it works. So it also works in a 5 volt. So it doesn't have 3 pins, just a 5 volt and a ground only. There is no signal pin at all. There is only 2 pins. So whenever it gets closed, value is 1. Whenever it gets open, value is 0. So this is how it works. Like already. So this is one of the soil moisture sensor. So soil moisture sensor, this plays a vital role in agriculture in nowadays. So many agri area you can use soil moisture. So they place the n number of soil moisture sensor based on the places. So based on the readings of the soil moisture sensor, they can able to automatically they can able to know whether water is low, whether it needs to restart the pump and pour the water to crops, whether the crops need to be harvested, whether the soil is good, whether the soil has over water content, no need to turn the pump on, whether it already rainwater gets stagnant, so the soil moisture gets dry. So it is a resistor. So how it works means just wait. So if the notepad is visible, sir?
Sir, is visible, sir.
Okay, sir. Okay. So everyone knows what's Ohm's law. So V equal to IR. So this is how it works. So this is Ohm's law. So everyone knows what V means voltage, I means current, R means resistance. So how soil mass sensor work means R equal to V by I. So this is how soil mass sensor works. So it gives resistance value. Resistance means resistance voltage value. Resistance value is a voltage value. So how resistance varies? So voltage divided by current. Okay. So whenever there is more number of moisture, like water inside the soil, in water the current flow will be maximum. So whenever the current flow is maximum, resistance is inversely proportional to current. So due to inversely proportional, the resistance gets lower due to increase in current. Whenever there is a moisture is high, moisture is high means there is more number of water. So water is high. Moisture high means water high. So in water, um, current flow will be maximum. Current flow maximum. So I is inversely proportional to R. So resistance will be minimum. So resistance will be minimum. So the resistance will be minimum. So the whenever there is a moisture in the soil, so the output from the soil moisture sensor will be resistance value. It will be low. It will be in for example, it will be in a range of 0. If I use a 10 bit ADC, it gives value up to 1024. So the value will be across 0 to 100 in a range precisely, not correctly. So based on the water level, the resistance gets low. That same thing when the moisture is low, that means there is no water. So the crops need to be water. Moisture will be low, so the water is also low. So whenever the water is low, the current is also low. So I is low, so the resistance value will be maximum. So resistance value will increase greater than 500, 500 to 1024. It varies based on the resistance. So this is how soil moisture sensor works. Whenever there is moisture is high, current is high, resistance is inversely proportional. So the value gets lower. Whenever there is a moisture is low, water is low, then the current flow is also low. So the resistance will be maximum. So it is inversely proportional. This is how soil moisture sensor works. So everybody clear with how soil moisture sensor works? So okay, or shall I tell me once again? So soil moisture sensor, it works based on Ohm's law. So V equal to IR. So it gives default resistance value. So R equal to V by I, voltage divided by current. So whenever there is more moisture, the water will be high. So the current flow will be maximum. So generally I is inversely proportional to R. So whenever moisture is maximum, the resistance value will be minimum. So whenever the resistance value lies along 0 to 500 value, you don't need to power on the pump or motor for watering because there is already water is present. So this is how it treated. So whenever the moisture will be minimum, it needs to, plants needs to be watered. So the resistance value will be maximum due to low in current flow, inversely proportional. So this is how it works. This sensor cost around, each sensor actually cost around 200 to 300. It's a minimum type sensor. So whenever we go for high resistance, so value gets increased. Means cost gets increased. So it cost around 180 to 300 something correctly. So based on the seller, but all the sensors has been lies along 0 to 300 only. It's cost rate only. That is a minimum type sensor. So we can able to easily buy it and use it, use the sensor. So this is how soil moisture sensor works. So based on your area, so whenever you need to automatically water your plant when you go out without watering the plant, so it automatically gets water once the power will be maximum. You can use battery power instead of DC power. So by a 9-volt battery, you can able to power it, but its operating voltage is 5 volt. You can't able to directly connect 9 volt to a soil moisture sensor. So this is how sensor works. So soil moisture sensor works. So next sensor is PIR sensor. PIR sensor means passive infrared sensor. Okay. So it's one of the IR sensor. So based on the motion of the object, the value gets changed. Okay. So it is one of the passive sensor. So based on the motion, it's one of the digital type. So value will be either 0 or 1. So whenever there is a change in motion, so value will be 1. Whenever there is no motion, so 1, 0. Sorry. So based on the motion only, it gets worked. So motion means whenever a object gets moved in front of it, based on the IR radiation, the value gets changed. So there is no commercial name. So we just purchase from local for working, not for industry. I just tested all the sensors. So you can buy it from any other like 11, 14. So any other vendor you can able to buy the sensor. So whenever you go type PA sensor, this type of sensor only. There are different types of vendors. So can able to buy any of the sensors. So all the sensors can be interfaced with this type. So which sensor you need, you can just buy it. There's no particular commercial name. You just ask for PA sensor, or you can able to buy it. So this is how PA sensor works. So PA sensor means whenever a vehicle has been come inside the garage, you can use PA sensor also for automatic lamp powering. So whenever a person comes in front of the gate, you can able to go. So where are the things you need to use PA sensor? You can able to, but it's not high efficient. Um, for example, if the person is standing still in front of that, it won't work. There is need to be a motion in front of this sensor to detect it. So it has some fault. It has some limitation. So based on your purpose, where you can use it, also cost around 200 something, 180 to 200. You can buy it. So it is IR sensor. So IR sensor is maximum we see IR photodiode in front of the remote for transmitting signal. So it has two LEDs for a powering LED for a transmitter and receiver. So white LED is for transmitting signal, black LED is for receiving. So whenever you power, this is a digital type, so you can use it for whatever purpose. It's a 5-volt operating system, so 5-volt ground and out pin. So whenever you power it, the LED gets blinked, and every time the light rays can be transmitted to an object. So whenever object is placed in front of the sensor, the light gets reflected back to the IR sensor. It is received by the photodiode, black diode, so it can receive it. So based on that, whether the object is come in front of it or it is not, you can able to find it using IR sensor. Uh, Based on the purpose, you can use what other things you need. So only limitation is in IR sensor means whenever you place a black object in front of an IR sensor, you can't able to find it because black is an observer. So whenever the light ray passed from IR sensor, the light ray gets observed by the black object. Whenever you place a black box in front of it, the light ray gets absorbed by it. So there is no data comes to our IR sensor. So we can't able to find whether the object is come in front of it or not. So that's one of the limitation in IR sensor. PR sensor means it needs to find motion. Working wise difference between PR and IR means PR works based on the motion. So you can place any of the object, whether it's a black, white, whatever the object you need, but the object should be in motion. So the object should be moved here or there. So you can't able to place the object at still. You can't able to measure using PIR sensor. But when you come for IR sensor, the only limitation is you can't able to place the black object. Other than black object, whichever object you need to place it and find it, you can able to find it, whether object is there or not. So these are the difference between PR and IR. PR means it only detects motion, but it has a limitation that without motion, the data will be zero. So there is no data. So it has limitation PR. When it comes to IR, it has also a limitation. So whenever a black object is placed in front of it, even it's an object, uh, it is close to the sensor, it can't able to find it. So whenever you place some other objects, the light ray gets reflected from the object. So it is used to soil hydration level. I know I didn't know how to find specifically hydrogen level in soil. Soil moisture used to detect only moisture only. But we can, I think we can go for pH metric. So I didn't know specifically, but I can tell you once I search it. I didn't know how which sensor to be used in hydrogen level, soil hydrogen level measure. So I can search it and tell you whether it can able the sensor can be available and whether even if it is available, whether the sensor can be able to interface with the Raspberry Pi or not, or some other controller. I can tell you. So this is the difference between PIR and IR sensor. This is one of the SD card reader. So SD card reader is not a sensor, so it's just a reader. So whenever you need to store any attendance file or some other things, you need to store it from the persons or not. You can use the SD card reader for writing and text file, storing an image, reading and file, reading a data from that. Can go for SD card reader. Okay. You can able to interface the SD card reader also with the Raspberry Pi because it is an SPA communication only. So it has 5 pin. So VC ground it operates in 3.3 volt. Okay, it not operate in a 5 volt SD card reader. So MISO, MOSI. So mainly, for example, you just consider whenever the sensor is an SPA, even it's not a sensor. So whenever anything is an SPA communication, for example, not all the SPA communication is operating voltage will be 3.3. For example, like SD card reader, RFID, GSM module, sorry, GSM not, GPS. So all the things, the operating voltage will be 3.3 volt. Other than that, all the sensors will be in 5 volt. So this is one of the SPA communication pins. So it is having VC ground, master in slave out, master out slaving, clock pin, and chip select. So it is used to track, store and transfer the data. Okay. So it operates in a 3.3 volt. So it's one of the SD card reader. So this is one of the NFC module. So NFC means near field communication. It operates, its ranges between 2 to 5 centimeter only. So it works on. So for attendance in your office, in your college or other things, just tap the ID card with the RFID reader. So based on the ID of the RFID card you are having, you just tap it. So the card number gets stored. So the attendance gets automatically stored in a back. So they are using RFID reader inside that thing. So RFID is majorly used in all schools and colleges, some other things for attendance purpose, for vending purpose, or for all the things we use RFID. So it's an now they are using credit card machines are in NFC only. So based on the frequency, you can't able to use you are not able to use credit card in attendance portal, like because both are working in NFC. You can't able to place both the thing in same. Based on the frequency, the card gets worked. If your RFID reader works in 125 kilohertz frequency, so 125 kilohertz frequency card only worked under NFC based on your reader, so 100 kilohertz. So this is how RFID works. So based on your purpose, you can use. Its ranges will be short distance only. Okay. So this is one of the sensors. So this is the humidity sensor. Okay. So humidity sensor is used to find the it is a DHT11. So there is a sensor like DHT11, DHT21, other thing. So these are used to measure the both temperature and humidity of the environment. Environment temperature and humidity can be measured using this sensor. It is a 5-volt sensor. So it has a 5-volt ground and one signal pin. So it is a resistive type humidity sensor only. So it acts as a both digital and analog. So it can be easily interfaced with it, and instead of LM35 you can use this sensor for capturing both temperature and humidity value. So based on this sensor you can able to use it. So this is one of the type sensor. Okay. So these are the basics of sensor. So anybody having any questions in sensor? So type of sensor, does it work same way as soil moisture sensor? No, it doesn't give us the resistance value. It gives only voltage value, like different sensors like soil moisture, sorry, smoke sensor, temperature sensor gives voltage value. Based on the voltage value, we can able to whenever we go for analog sensors, some of the sensors have defaultly have libraries. When you take an example as uh, temperature sensor. So temperature sensor has a LM35 library function. So based on the voltage value mentioning from gaining from this sensor, they defaultly no sorry humidity and soil moisture. No. That is not humidity and soil moisture sensor. It is a humidity and temperature sensor. So it measures temperature and humidity only, not soil moisture. Soil moisture, you go for only soil moisture sensor. So it measures temperature humidity of environment, not soil. You can't able to place this inside the soil. It doesn't measure it. Okay. Yeah, pH level it's available. pH scale. So like pH sensor, it's available. It's look like just like soil moisture sensor. It has a long tip. So based on the pH level, it has a library function. So based on the pH level, it's an acid base. So there are a number of pH values. So based on that, it detects it. That's sensor. pH value as sensor. We used it pH sensor, but I didn't know whether the sensor is available for soil hydrogen level. I can check it and get you. Some sensor used for healthcare application means based on the purpose for heart rate measuring, there is a heartbeat pulse sensor. The name only is a heartbeat pulse sensor. So based on the oximeter, how oximeter has been measured, like placing inside the finger. Likewise, they fix the sensor inside the finger of the patient. So they measure the heartbeat of the person. So that's where we use the heartbeat sensor. So based on the application, you can use so whether we need to find some other things. So healthcare means there is a number of things. So each thing has sensor. So each thing has different capabilities for temperature measuring, for pulse measuring, for heartbeat, for blood pressure, for what oxygen level. Yeah, a number of things in healthcare has application. So you can use uh, based on your application. So what are the things you need to measure for the portion? Can the sensor be manipulated? So I didn't get you. So manipulated means you how you're telling. So I didn't know. Can sensor be manipulated? Can we be more specific? So what are you asking? I didn't get you. So for example, if you are using mm, yeah, but it's minimum level. It costs around only 150 to 200. For testing purpose, you can use this sensors. Whether you need to use soil moisture for just your watering your plant only. So other than things. So it is easily being hacked. Whenever there is an issue with the power supply, it can give a false reading. So each sensor has limitation. If we want precisely for healthcare for monitoring in patient means it could be more precise, should be more correct if you use for healthcare because it is a life thing. So we can many companies providing sensors with a more precise value. Okay. For example, for ventilator, we go for a flow meter sensor, flow sensor for oxygen level. We can use what I didn't get the name. So Bosch itself having different sensors. So we used one of the Bosch sensor for RFID. RFID means if you want to delivering, Flipkart is transferring a package from, for example, Flipkart is transferring a package, goods from one place to another place via vehicle. Each vehicle has an one RFID transmitter and also GPS with it, so that the person can easily be tracked, not user. In their company, they can be tracked based on the RFID. So each what each vehicle has a one RFID ID reader, so they can transmit the data using GPS to a source, to a main control room, so they can able to track where the vehicle has been going. For that purpose, we can't able to use our RFID because due to lower range. We can use some other sensors based on different industries providing. So I didn't get any industry name now, so I can tell you afternoon. So what are the sensors we use for that purpose? But it can be hacked. Yeah, it can be hacked because due to minimum configuration, it can be hacked. False reading, there is a lot of reason for false reading. Whenever the connection is not proper, the reading will be false. So there is many limitation using this sensor. For minimum purpose, we can, for testing purpose, we can use this sensor. For more precise value, we can go for higher end sensor. So based on the precision value, we can able to use the sensor for oceanographic thing to measure the depth of the sea level. We can't able to use this ultrasonic sensor, so we can go for that for a higher end version. So the cost will be more. So whenever the cost will be more, the precision will be more. So I tell you that Omron sensor, one of the temperature sensor. So it is used for measuring the person's body temperature based on the temperature. Digital thermometer, they use Omron sensor only. They didn't use our LM35 sensor because it isn't low and it's for testing purpose, not highly precision. So based on your purpose, you can use, and it can be hacked. So can be used based on that. So any other things in sensors? Shall we go how ultrasonic sensor has been interfaced, how coding? Any other queries on sensors section? Anything needed? So okay. So I will explain how ultrasonic sensor has been interfaced with the Raspberry Pi and how to code that ultrasonic sensor. So if you have any doubt in sensors and if you need to know anyone, kindly ping me. So we already know ultrasonic sensor is an used to find the distance from one place to another place, one place to another object. It's a distance. Based on that, its maximum range will be 4 meter only. Maximum range will be 4 meter. So it can be used for lower purpose only. So for IR, they are transmitting light waves. For ultrasonic, they are transmitting sound waves. So all are low frequency only. So it is inaudible to human ear. Okay. So it has 4 pins: VC, trig, echo, ground. VC means 5 volt, trig means trigger pin, echo means echo pin, ground means ground. Trig pin is used to trigger the pulse from transmitter. So the transmitter pulse is triggered from transmitter side and goes and hits the object, and the receiver side it gets received via this echo pin. So the echo pin is used to receive the pulse, and it's converted the pulse into value. So you can't able to measure the distance or some other things using pulse value. So you need to convert pulse to value. So echo pin is used to receive the pulse from the outer object after hitting the object. Okay. So after receiving it, it converted, and speed of sound in air 340 meter per second. You just convert it and just calculate it. Speed equal to distance per time. I will show you how the distance has been calculated. So this is how ultrasonic sensor works. It provides a trigger signal pin to trick pin. So trick pin is an input. So real-time example of measuring overhead water tank means, yeah, you can, if you go for a lower version, if you do your project at minimum version, you can go for some other controllers. Like there is a number of cheap microcontrollers. Like if you take Arduino Nano, it costs around 250 only. Uh, so you can able to use that sensor to interface ultrasonic sensor. So just place an ultrasonic sensor for measuring the level of the water in a tank. So based on the tank, you just connect a relay with the solenoid water flow to check the water flow. So whenever the tank gets filled, automatically the data has been passed, tank has been full. So the controller close the solenoid valve. So whenever the solenoid valve, it closes the relay connected with the solenoid valve. So whenever the relay gets closed, its access switch. Whenever the relay gets closed, solenoid gets closed, so the water don't come up. So for this purpose, you can use Arduino or other thing. You can also go for Raspberry Pi if you need to measure how many times the motor has been switched on at particular day. You need to maintain that thing. So all the things has to be connected with the internet. If you need that kind of things, if you want whether to automatically switch on the water tank motor based on the water level, you can't need internet or all the things. You don't need an external Wi-Fi module for transmitting data. If you want to maintain how many times the motor has been switched on in a single day, or okay, how fast the tank has been filled, uh, if the motor has been run for half an hour, you can maintain some other data. Which other person gets switched on motor, whether house one or house two. So each house has a separate motor connection. So you can able to measure all the things with connecting to internet. So for internet, whenever you go for Arduino, you can't able to transfer the data directly. So you need to use another Wi-Fi module to interface with it to transfer the data. For that, not Wi-Fi, you need a Bluetooth module. Whatever communication module you needed, whether Bluetooth, you can use either Bluetooth or 430 RF transmitter receiver or LoRa. Can't able to use NFC so for transferring data. So these are the external modules you needed. But when cost-wise compared to it, each module gets increased. But Raspberry Pi defaultly has Wi-Fi. So whenever you fixed it, all the things, you can able to transfer the data easily through Wi-Fi because it defaultly has Wi-Fi. If you want Bluetooth and you need to view the Bluetooth value, if you are in a particular range, you need to view the motor is switched on or not. You can able to transfer the data using Bluetooth, so it can be used using Raspberry Pi. So whenever you use Arduino, you need a separate Bluetooth module, HC05 module. We use. Okay. So, Prabhakar Lakshman. So are you clear? Thank you. So HCSR04 is one of the type of ultrasonic sensor we are used. There is a number of ultrasonic sensors, so each can be interfaced. You can able to check it. So here I use HCSR04. So working is it has a trig input. So you need to provide input high pulse at least 10 millisecond duration. 10 microsecond you need to switch on and off so that the sound wave gets transmitted using a trig pin. 40 kilohertz ultrasonic beam. It gets transferred to a transmitter. If there is an obstacle in front of a module, it reflects those ultrasonic waves And if signal comes back, the echo output of the module will be high for a duration of a time for sending the ultrasonic waves. The pulse width ranges. So based on the range you send it, how many pulse you send for 2-second delay, for 3-second delay, for 10 microsecond you are sending a pulse. So how fast it comes based on the time duration, distance can be calculated. Okay. If there is no obstacle, time take will be more. So you can check whether the target is further or it is nearer to the object sensor. So voltage divider. So this is the main part in compared to Arduino or some other thing. In Raspberry Pi, while we are using sensors like input sensor, so each sensor has been an input sensor. Okay. So for each sensor, I told you at morning session 1 that all the GPIO pins acts only in 3.3 volt. So whether it's an input pin or output pin, it acts only in a 3.5 volt. Sorry, 3.3 volt, not 5 volt. So there is a 5 volt port also. So whenever you see there is a two 3.3 volt and there is a two 5 volt port. If you need 5 volt, you go for 2 and 4 pin. If you need 3.3 volt, 1 and 17 pin. But if you connect sensor, you need to power the sensor, you need to give either in a 3.3 or 1 or 17 or else 2 or 4. Either 4 pins only you can give the power the sensor. If you need to read the data, so each GPIO pin, so any GPIO pins you can be able to use it, but each GPIO pins only accepts the input about 3.3 volt. But if the sensor is operating voltage is 5 volt, the input also will be in 5 volt. So you can't able to connect the sensor directly to the GPIO. I'm telling not powering the sensor. For VCC, based on 5 volt means you can connect the 5 volt pin. When it's a 3.3 volt, you can connect the 3.3 volt to the VCC for powering the sensor. For accepting the input, for fetching the input from the sensor, you need to connect to a GPIO pin. So either it's an analog pin or digital pin. The data has to be fetched based on the GPIO pin which you have been connected. Okay. So in ultrasonic sensor, you know there is a two pin. Other than VC and ground, there is a two pin. One is trig and another one is echo. Trig pin is you are sending an input from Raspberry Pi through ultrasonic outside, right? You are generating a 10 microsecond pulse from Raspberry Pi. You are sending a voltage to ultrasonic sensor. So ultrasonic sensor sends the pulse wave to outside environment. Okay, this is how it works. So after the pulse gets hit to an object and it gets reflected back. So sensor is fetching the input from the environment. That means the reflected wave. It fetches the input from the environment and gets fed to a Raspberry Pi. So it is accepting an input and feeding to a Raspberry Pi. So in trig means the Raspberry Pi is sending an input via ultrasonic to the outside environment using trig pin. So after reflecting back wave has been observed using receiver side via echo pin and pushing the data inside the Raspberry Pi. So the Raspberry Pi converts the voltage value and gives a precise value, digital value. So this is how it works. So I'm told you GPIO pins is 3.3 volt, but the operating voltage of each sensor, 5 volt sensor means all the sensor operating voltage means 5 volt. So you can't be able to connect 5 volt input pin to a GPIO pin directly. So that's why we used voltage divider by. So for each sensor input side, we used voltage divider by. See, the echo output is 5 volt. The input pin of Raspberry Pi is rated 3.3 volt. So 5 volt cannot be directly given to unprotected 3.3 volt input pin. Therefore, we use voltage divider circuit using appropriate resistor. Okay. So Vin means it's a given input voltage. So 4.7K resistor. So you know 4.7K resistor and 10K resistor. So this is how the circuit has been given. So you connect 5 volt, that means a echo pin to a resistor one end and resistor another end is putting in the ground. So both resistor connected to one end. So the output will be V out. So see the calculation. So 5 to 3.3 means V in means 5. Just a minute. See, V out equal to V in into R1 divided by R1 plus R2. So this is the formula for voltage divided by S. So V out means you need 3.3 volt, right? So V in means 5 volt. That means echo pin. So 5 divided by, 5 into R1. R1 means 4.7K. 4.7K means 4.7 into 10 power 3. Okay. So just calculated it and divided by, whole divided by 14.7K means into 10 power 3. So this is how it is treated. When you calculate it, it comes approximately around 3.3 volt using this calculation. So whenever this out pin has been given to any GPIO pins where you can measuring the ultrasonic waves. So this is how it works. So this is the formula for voltage divided by S. So this is how voltage divided by S. So each sensor need to be connected. Whenever the operating voltage of sensor will be 5 volt, you need to go for voltage divided by S before connecting the signal pin to a Raspberry Pi, any GPIO pins. So you need to use this voltage divided by S, 4.7K, 10K. So based on this calculation, you can use whatever resistor you needed, but try to be used 4.7K and 10K so that there is no loss between input and output voltage. So that's how it's used. So this is how sensor is connected with Raspberry Pi. If you want to take a snapshot or note it, I can provide the document within today. So can able to see how the sensor has been connected. So just here look at. So VCC is connected directly to the 5 volt of the GPIO. So just see it, 5 volt of the GPIO is connected to ultrasonic sensor. Trick pin is connected to one of the GPIO pins. Okay. So it is an input pin. So the value is given from Raspberry Pi to ultrasonic. So it is not an issue to directly connect it to ultrasonic trick pin to a Raspberry Pi because Raspberry Pi is sending a data to ultrasonic sensor. So that range will be varies from 3.3 to 5. It's not an issue. So we can able to connect directly to a trick pin. But echo pin means after receiving the data, the echo pin has to be pass the data to a Raspberry Pi. So the Raspberry Pi in Raspberry Pi we can able to see the data. Okay. For that purpose only we can using the voltage divider bias. Okay. For converting a 5 volt input into a 3.3 and given to a GPIO pin. Okay. See, then ground to a ground pin. So this is how it is connected. So I will show you so how to connect it. So if is it visible?
Sir, yes, sir.
Okay. So here it is an ultrasonic sensor. So it has a four sides. So 5 volt, rig, echo, and ground. Okay. So it is a breadboard. You know breadboard. So just a minute. So this green color is a 5 volt pin. So green color wire is a 5 volt. So it is directly connected to the 5 volt of Raspberry Pi. So second pin is trick pin. Trick pin is connected to a some other GPIO. Okay. Third pin is echo pin. So echo pin is connected to 4.7K, one side of a 4.7K R1 resistor. So this is R1 resistor. So color code is violet, red, gold or yellow. You can take it. Okay. So color code is red, violet, yellow. It is a 4.7K resistor. So I connected echo pin of the ultrasonic sensor to the one end of the resistor, 4.7K resistor, and another end of 4.7K resistor and 10K resistor. 10K resistor color code is orange, black, brown. Orange, black, brown. So this is 10K. So you know how to calculate resistance value. So you just connect two resistor in single part, and I'm taking out pin from that point at middle where both the resistor meet connected. I'm taking out pin. On another end, I'm connecting a ground. So see, so I'm giving a ground of the ultrasonic to the other end of a resistor, and I'm taking a ground pin where I'm ground is connected to a Raspberry Pi. So this is how ultrasonic is connected with voltage divider bias. So any doubt in connection? Okay, so 5 volt directly connected to Raspberry Pi. Rig is directly connected to Raspberry Pi. Echo is connected to the 4.7K of the resistor one end, and both resistor connected to one end. From there out is taken. On another end of resistor, ground is connected, and the ground pin is taken to connect. These two pins are connected to the Raspberry Pi. So there are 4 pins. So 5 volt is connected directly to VCC is connected directly to the 5 volt of Raspberry Pi. So trig is directly connected to the GPIO. Echo is passed towards this voltage divider, and the out pin is taking echo pin underground. So this is the 4 pin. So first you see the code, how code has been written. Since the code is visible. So this is how you code it. So first you need to import. Okay. So this is how you write a code. First we need to import time function and GPIO function. So you already installed rpi.gpio library. So I told you while I installing the basic packages at first session 1. So we need to install it so that we can able to use the GPIO pins. So import RPI rpcaps ismod the GPIO as GPIO. This is how you import the library file. So after importing library file, you just given a common name as GPIO. So you can able to fetch the functions from this library from GPIO dot. It's like an object. So you are creating it. So then import time. So time function has been imported. So this is the two import function you need to done. So import, see the right side. So import GPIO library, import time library. Okay. See, in Python, there is no syntax like curly brace, semicolon, comma, so all the stuff has been not provided. So indent should be properly done. So without indentation, there will be an error. So please take care of indentation. So indenting is must. So please provide proper indentation. So after importing two functions, so we need to set the mode. BCM means board pin. So we need to enable the GPIO pin. So whenever the GPIO.set mode is GPIO.BCM is 1, so that the GPIO pin gets worked. So this is the must function for whenever sensor is connected. GPIO.set mode will be GPIO.BCM. So that any other sensor connected to a GPIO board started communication. Okay. So then trick 20. Then to like variable name. I'm creating a two. So I've told you. So BCM means, so I will show you while I'm showing the features. I'll show you. Just go broadcam. It's broadcam. So it is features of our, see, it's a broadcam. Broadcom means it's a communication. So it is one of the BCM's library, default library. So that whenever you import BCM, so when you use to set the mode, so it's a broadcam code. So broadcam module. So that is BCM. So whenever you use broadcam, so that we can able to connect with the GPU open. So this is how it works. So we need to set that mode whenever we are using a GPU. Okay. So whenever you are writing code, so in any places like in IT, in company, in others, the code should be reusable. So whenever you are working in a project, not every project is be handled by same person from scratch to in from production. Same person can't able to find the code. So the code, whenever a developer has to be written, it should be reusable and it should be easily known whenever a person is looking into the code. Because if one person gets switched to another company, so another person need to go ahead with the same project. So they need to find the project. Whenever he comes under any doubts, he need to communicate with that person. So it is a vast process. So to eradicate that, whenever it's a well developer, they need to write a code within a reusable manner. So whenever which person just read it the code, they can able to easily understand the code. So that's why we are measuring, we are mentioning, we are using global variables. So global variables, whenever global variable is declared, so we can able to use easily the global variable at any point. So here, trig means trig pin, echo means echo pin. I'm mentioning 23 and 24 is not pin number, it is a GPU pin. So please be clear. So whenever I'm giving a number, pin number, it is not an what pin number, ordinary pin number. So like we see in GPU pins. So like this. So I didn't mentioning the pin number like 1, 2, 3, 4, 5, 6. I didn't mention the pin number. So it isn't GPU number because you are enabling the GPU pin. So I'm giving 23 and 24. So look here. So GPU 23 means 16th pin. GPU 24 means 18th pin. From this round circle, you whenever you connecting this, you please look after this pin diagram properly, so you can able to go. So whenever you taken 23 and 24, you just connected with the 23 and 24 from here. GPU 11 and 8, it won't work. So please, whenever you mention the pin number, it is a GPU pin. So please mention, please cross check, cross verify with the pin diagram. Then you write a code. So I taken GPU 23 and 24. You can able you can able to use whatever GPU pins you need you wanted. Okay. Okay. So trick pin means 23, echo pins means 24. So whenever a person reads this code, so they can easily understand that trick pin is connected to a GPU 23 and echo pin has to be defaultly connected to GPU 24. If I want to use another ultrasonic sensor, they didn't use same pin. So if they need to change the pin number, they just want to change the global variables value only. So they didn't need to change wherever the 23 has been replicated. They need to change all the thing. If they fail to change that any specific thing, the sensor won't work. So it is well mannered to use a global variable at start of the project. Any doubt? Okay. So trig pin, echo pin, I'm just measuring trig and echo. So then I'm print distance measurement in progress, just a double quote. So you need just to mention whether the measurement progress has been started or not. I'm just denoting. So it is a line by line execution process, Python means. So it starts from top itself, from line by line it gets executed. So after print distance measurement in progress, GPIO setup pin. You need to set the pin, trigger and echo pin. Which pin is out pin, which pin is in pin, because GPIO is general purpose input and output. So each pin acts both input and also an output. So a microcontroller can't able to think on its own. Whenever you write a code, based on the code, the controller gets think. But without giving proper information in your code, the microcontroller can't able to think on its own. So it doesn't know whether they need to fetch the data from the sensor, or they need to send the data from the controller to a sensor or some other component. So you need to set the mode. So setup is a must. So for all the thing, you need to set what the pin has to be done. So here you already know trick pin is used to send the data from Raspberry Pi to via sensor to the outside environment. So trig means the 23 number should be come here. So because it is a global variable, so variable name has been given. How do we come to know which? No. Always trig will be output, echo will be input. It is a default. So you can use whatever the pin number you want. Okay. Right. So GPIO.out means out pin. So trig means always out pin. So always the data has to be sent to the outside environment. So whenever data is sent outside, so it is an out pin. Whenever the data has been fetched from outside to inside to the controller, that is an input. So for ultrasonic, trig means always out pin. Echo means input. Okay. So trig comma GPIO.out. So out pin. So echo means it input. So GPIO. GPIO means RPI.GPIO. It is an object name. So object.out means out pin. Object.in means input. So here object name is GPIO for RPI.GPIO library function. So GPIO.setup. So we need to set this function. So I'm running always true function. After this is the one time setup. So whenever the pin is set, always the pin acts as output. 23 acts as output. 24 GPIO acts as an input. Okay. So I'm running a loop while true. So GPIO.output trig comma false. Actually, I'm sending in square wave. So for example, if you are sending in wave, you can't able to send a half wave or from one. You can't able to send the waves indefinite. You need to send a proper one full wave for 10 microseconds. So one positive full cycle, one negative full cycle. For that purpose, you need Raspberry Pi generates a wave and sends via trig pin. So for generate purpose, first of all, we need to zero the pulse trig pin. So the position starts from 0, then 1, then 0. So one full pulse, one positive, one negative pulse. So first of all, we need to start from 0. So one positive, one low. So it is a digital pulse. So high, low will be mentioned. So high means one positive cycle, low means one negative cycle. So this one full pulse. The total time period is 10 microseconds. So okay, that's why we are first setting trig pin as false. So we are setting the starting point of the pulse to 0th position. Okay. So we wait for time dot sleep. Time dot sleep means it's a delay function. So 2 means 2 seconds. So 2 seconds of a delay. That's why we import time function for the delay purpose. Delay means wait. It waits for 2 seconds. Okay. So then GPIO.1 true 0.0001. That means 10 microsecond. So you know 10 microsecond means 10 power minus 6. Milli means 10 power minus 3. Okay. So 10 microsecond delay, then trig comma false. So one true pulse, one false pulse. Okay. So one high, one low for 10 microsecond frequency. So you know F equal to 1 by T. So 10 microsecond delay. So this is the first setup. Okay. So then I'm receiving the pulse which are sent via ultrasonic sensor. So while GPIO.input, so echo is the input, So 24th pin is input. So whenever the reflected pulse comes from the object received via echo, the echo pin gets 1. So whenever there is no pulse, the output will be 0. Whenever there is a pulse, the output will be 1. Okay. So I'm just starting the pulse time. So 0 means I'm calculating the time. Uh, uh, if the pulse is transmitted first from trick pin, the echo pin will be 0 because the pulse is traveling towards the air medium and going to hit the object. So the echo pin is waiting. 0 means it starts the time. Okay. So whenever the echo pin gets 1 means the pulse which is transmitted via trick is received in a echo pin. So the pulse gets acquired via echo pin. Okay. So the pulse gets increased, acquired by the echo pin. So the value gets 1. So whenever the echo pin gets 1, I need to stop the pulse. Okay. So I'm stop the time. So I am storing the time in pulse in. Okay. So here I am doing just measuring the time travel. So how pulse, how long the pulse need to be transmitted and received. So this is how I'm starting. So whenever the trick pin gets started, I'm monitoring the echo pin 0. I start the time. So whenever the echo pin gets 1, the reflected wave gets received via echo pin, the value gets 1. This is how value is acquired. Okay, this is how value is acquired. So the time has been calculated from pulse start to pulse end. Okay, so I'm now measuring the pulse duration. So pulse duration means pulse end minus pulse start. So I can get a pulse duration value. So how long the wave gets taken to hit an object. Sir,
Sir, sir, the technical session 2 will likely to end up.
sir, give me 5 minutes so I can able to finish this code. After lunch, I can show the working of this ultrasonic code.
Please, sir, please.
Okay, sir. Okay. So I'm getting a time. That how long the pulse gets transmitted and received, I can get the time interval. So based on the time, speed equal to distance by time. So distance equal to speed into time. So this is the default formula you already know. So here distance is one of the variable. In Python, you don't need to mention the data type, all the steps. It's a variable name. Distance equal to pulse duration, which is you get from the pulse, which is a time into speed. So 17150 is what means. Look here. Distance. So speed of sound in sea level or in air, whatever medium, it's a 343 meter per second. Okay. Speed of sound in air. Sea level means air. Sea level means above sea level. It means air. Okay. 340 meter per second. So which is 343,000. I'm converting it to a centimeter. Okay. Meter per second means centimeter. So 100 centimeter means 1 meter. So I am multiplying it with 100. So 343,000. So distance equal to 17150, which means time interval means the object starts from one end, goes and hits the object, and then gets reflected back and reaches the same point. So it takes twice. So we need time interval to reach that object only. So we divide the total time divided by 2. So we can get only transmitted time. So 343,000 divided by 2 means 17150. This is the speed of the sound and air. Okay. So look, we can get time and into speed. So speed into time is distance. So I can round the distance with the 2 decimal point. I can store the distance in a distance variable. So I'm checking whether the distance is greater than 2 and between 2 to 400 means it is within the range. So I can print the distance. So if it is out of range, which means it is other than 4 meter, value will be some other garbage value. So you can't able to measure the precise value. So this is the complete code structure. So I will once again explain after lunch, and I type the code and execute it after connecting this, and I will show you after the lunch. Okay, thank you. Sir, is it okay, sir? So we can wind up this session too.
Sir, shall we wind up the technical session 2, sir?
Sure, sir. After lunch, I can go. I can continue with the working and session 3.
Okay.
Okay.
Dear participants, you have any query in the session 2?
So I will explain the code once again after the lunch will be over. So I will explain another
Okay.
code.
Okay.
So
Right. So it is time for us to go for lunch. So at this August session, I would like to give the conclude note for technical session 2. The resource person of technical session 2, Mr. D.P. Kishore Kumar, has explained about various sensors like vibration sensor, ultrasonic sensor, touch sensor, smoke sensor, temperature sensor, then magnetic reed switch, soil moisture sensor, then vibration sensor, PIR sensor, then IR sensor, then RFID reader, then humidity sensor. I hope this session will give you some knowledge about understanding sensing actions. So with this, I want to end the session 2 of day 1. Okay, thank you.